even and odd properties of definite integral. So the first one is even properties. So let's say the function f is an even function. We have a definite integral from negative a to a f of x dx that is equals to 2 times 0 to a f of x dx. So the example that I will be using is I have a parabola upside down, negative x squared plus 4, and then I want to go from negative 2 to 2. That is the same thing as 2 times the integral where x goes from 0 to 2. Take a look at the graph right over here. So we have an upside down parabola, and then from negative 2 to 2, so the sum is supposed to be 32 over 3. So what I am trying to do is I'm trying to go from 0 to 2. I'm going to get the piece on the right, and then after I evaluate the integral, I multiply by 2, and then I will get the sum. What is the purpose of doing this? Most people are just ask, hey, that is not a lot of work. So why don't we just go from negative 2 to 2? Yes, you can just go from negative 2 to 2, write the integrand dx, and then just evaluate the integral. You will get the answer, but we would like to discuss these properties. If you just ignore the properties, yes, you can get to the right answer, but it is good to take a moment to discuss these properties. Okay, let's do the integrand. So the integrand is pretty easy. So antiderivative, remember, I think the easiest place where you make the mistake is you forgot the 2 at the very beginning. Okay, antiderivative of negative 2, negative x squared. So that is x to the third, right? Negative 1/3, and then 4 is 4x. And then this goes from 0 to 2. And then you do the plug-in. I will write the 2 first. So since we will be using many parentheses, I will just use a big square bracket. So plug in the 2, you have a negative 1/3 times 2 to the third, right? And then plus 4 times 2. So this is the upper limit. And then the lower limit is your minus. Everything becomes a 0, but we want to write anyway. Plus 4 times 0. And then close parenthesis, close the square bracket. So this one, what do you have? This one gives you a 2, and then 16 over 3 minus 0. And then this one is equals to 32 over 3. Okay, this is the total area. I want you to take a look at this line right here. Do you see that I have a 16 over 3 minus a 0? So 16 over 3 minus a 0. So basically the area of one side. So what do I mean by one side? So the area of this piece is 16 over 3. So I just get this integral and then I multiply by 2. What is the benefit of doing this? Like I said at the very beginning, if you just go from negative 2 to 2, yes, you can get the final answer without multiplying by 2, and you don't have to take the risk of forgetting multiply the 2, right? What is the benefit of doing this? Whenever I make a definite integrals for exams, I really like to use the 0 as for the either the lower or the upper limit. Why? Because plugging in a 0 makes everything so easy. I think that is the only benefit. You can plug in a 0. So you can plug in a 0. So the benefit that I just got from this property is I can save some time for doing math right over here. So the 0 saved me maybe like 10 seconds. So that is the only benefit. And then once again, don't forget to multiply the 2. Okay, don't forget to multiply the 2 when you use these properties. And then the next properties is the odd function. So for the odd function, I have from negative a to a, g of x dx, and then g is an odd function that is equals to 0. Why is that equals to 0? I would like to use this very good example, the cube root of x from negative a to a. So from 0 to a, the area is equals to 12, but the other piece on the left, that area, that region is below the horizontal axis or the x-axis. So as a result, that area is negative 12. So you have a 12 plus a negative 12. That's why you get a 0. All right, so it looks like they just cancel each other, the positive and the negative. So let's take a look at the right side from 0 to a. Let's take a quick look at what that equals to. So this one, I should match the color, right? So this one, the antiderivative of that, this is a x to the 1/3. So 1/3 plus 1 is 4 over 3, reciprocal is 3 over 4, and then you have 0 to 8. So plug in a 0, super convenient, right? So you have 3 over 4, and then the third in the denominator, that is a cube root, so you have a cube root of 8, and then you raise the whole thing by 4th power, and then minus, you plug in a 0, everything becomes a 0. So what is that equal to? That is equals to 3 over 4, right? So that is equals to 3 over 4 times 2 to the 4th power, that is a 16, and then 4 times 3, that is equals to 12. So that's how I got the 12 right over there. And then this one, look, I'm going to use the property that we discussed in the previous video. So what happened when you reverse? Oh, actually, you know what? This is not reversing. Okay, never mind. So what happened when you go from -8 to 0? And then cube root of this. So this one, when you do the fundamental theorem of calculus, you will have a 3 over 4, and then the cube root of 0 to the 4th power minus 3 over 4, the cube root of -8. -8 to the 4th power. So this is just a 0. I know this is equals to 0. So this is just a 0. And then the other one, you have a minus 3 over 4. And then the cube root of -8 is -2, but you have -2 raised to an even power, to a 4th power. So that is equals to 16. So this one gives you a -12. So you have a positive 12 and a -12. So as a result, if you just go from -8 to 8, and then the cube root of x, so let's draw a radical first, and then the cube root of x dx. So this one is just equals to 0, because 12 plus a -12 is equals to 0. Alright, so that is the end of this video. If you like it, give me a thumbs up, a subscribe, stay tuned, and I will see you all in the next one. Signing out.